Hey class, welcome to Unit G, and this is part 1, and we're just going to take a look at the first couple of pages of Unit G, which is on graphs and tables. Before we do that, let's just take a look at where this fits into the course here. I'm going to go back to a diagram which I showed you before, which is something that we'll keep going back to. And we're taking a look right now at really this guy right in here. So it's under that first block of descriptive stats. That is, how do we make sense of a mess of numbers? And one of the ways that we can do that is to take all this data, let's say you got 10,000 numbers or something, and put them into tables. And then what we can do is we can make a graph out of it. So this unit, Unit G, is on graphs and tables. Let's get back to the right page here. And you might want to take a look at the first page here and read through on that. The subtopics that we'll be dealing with here are on data types, which is a really important concept here. And that's going to be actually the focus of this very short lesson today. And then I'll go on to the rest later, which will be on how to construct tables. And then we'll look at some graph types. At the very end, there's some data sets which are the data that we use when we're going through examples here. And what's really important for you to note is at the end of this unit and every unit from this point on are some additional homework problems for you to work on, not to be handed in, but they have the solutions there. And the expectation is that you prepare yourself for exams by working through those particular those problems and taking a look at the solutions. If you have any questions, of course, bring them up during office hours or during the asynchronous class, or there might even be time in the synchronous class. So just want to alert you to that. Let's go on to the second page here where we talk about data types. And this is an important thing that we're going to look at, and actually goes right through this course and the next course. It becomes even more important in 307 if you continue on with that. But we want to look at three main types of data, the way that data are classified: nominal, ordinal, and interval data. So nominal data, nominal comes from a Latin word which just means name. So it's named data or categorical data. So it could be things like, what is your gender, male, female, or other? What do you believe? Do you agree with this statement, or not? Yes or no? What city were you born in? If you were born in Alberta, Calgary, Edmonton, Red Deer, Grand Prairie, etc. So those are categorical in numbers. The thing to remember about them is that there's very little that you can do with them statistically. You can come up with the number of people in each category, and you can come up with percentages, and you can make a nice pie graph if you like on those sort of things. But you can't do something like calculate an average. So for instance, if you ask people to put down their gender and you've got a bunch of M's and you have a bunch of F's and you've got a few O's, then you might ask, well, what's the average gender? Well, how do you even calculate that? You can't come up with a number for that, right? The same with yeses and nos. What's the average here? You can come up with percentages, proportions, which one is more than the other, but you can't come up with an average, or later when we look at things like standard deviations or ranges or things like that. So you can't do a whole lot other than count them. The next category that we look at here, though, is ordinal data, and this is ranked or rated data. So I'm going to add here the word rated as well. Ranked or rated data. And so this is where I might say to you, on a 5-point scale, can you rate the taste of this soft drink, where 1 means it tastes really awful and 5 is, this is awesome, I'm going to go out and buy a case of it. So that is a rating scale. The important thing to note about ratings is that we know that a 5 is better than a 4, which is better than a 3, a 2, and a 1, and so on, but we don't know how much better. Let me give you an example. Let's think of a movie which probably most people have seen. It's Star Wars. How would you rate that on a 10-point scale? where 1 is really awful and 10 is awesome. Well, I would probably rate it around probably a 9 or a 10, and a lot of people I know would as well. But there's some people that would rate it as a 6, and some would rate it as a 7, some an 8. Now, is the distance or difference between one person's 6 the same distance between a 6 and a 7 as it is between a 7 and an 8? Well, we don't really know that, only that a 7 is considered to be better than a 6 and an 8 is better than a 7, but how much more, we don't know. Similarly, if I asked you to rate some movies, and is my 9 the same as your 9? And again, we don't know that. Is my 8 the same as your 8? Is the difference between the two the same? And again, we don't know. So that's when we're dealing with ordinal data. Now, ranked data is similar. So ranked data is where, for instance, think of a race, and you're talking about the people who come in first, second, third, and so on like that. If you're running a marathon and watching the Olympics, which unfortunately we didn't get to watch in 2020, but hopefully in 2021, if you're watching a marathon, they take place over a long period of time, like a couple of hours or more. And so if the person who comes in first may actually be 10 minutes ahead of the person who comes in second, and then the second person might be 10 seconds in front of the third person. So you got the first person, a big long break, and then the second and third are running neck and neck. All we know is, if we're talking about their rankings, is that this person came in first, this person came in second, this person came in third, and it doesn't say anything about their times, right? We just know that one gets the gold, one gets the silver, and one gets the bronze, not how much better one was than the other. Of course, that data is calculated in terms of times later, but in terms of just the ranking, all we know is first, second, and third, and so on. So that's ordinal data. You can do more with ordinal data than you can with just straight nominal or categorical data. So you can, of course, count the number of 1s, 2s, 3s, 4s, and so on, come up with percentages. You could come up with a pie chart or a bar graph or something like that. And you could come up with certain measures we'll see later in Unit C called the median, which is the center of the data, and so on. It's hard to come up with an average, though, an arithmetic mean, which we'll see in Unit C. So what is the average rating on this? And that's because, again, we don't really know the distances between the numbers. Interval data are the strongest type of data that we're dealing with here, and that's where we actually know the distances between the numbers. Probably most of the things that you're measuring are interval in nature. So if I asked you, what is your age, right? What is your weight? What is your height? What mark did you get on the exam? Those kind of things there are interval in nature. And that's because we know that, let's say you've got people lined up and you've got one person who is, say, 5'10", and another person is 5'11", another person is 6 feet, then the difference between them are 1 inch each. And you can say that the difference between person A and B is the same difference between B and C. It's 1 inch in each case. So we know the interval then, when you're dealing with time, volume, things like that. Number of units that we produce per week, number of visits that we make, number of people that come and visit our shop. Those are all interval data numbers. There's a special category of interval data called ratio data, of which most interval data actually falls into ratio data. And that is where the 0 is the starting point. So if we're talking ages, we say that a person begins their life at age 0. So therefore you can say that a 20-year-old is twice as old as a 10-year-old. See, you can come up with ratios, or a 10-year-old, of course, is half. That's the ratio, half of a 20-year-old. Some interval scales, though, it doesn't work for. An example would be a temperature scale in either Celsius or Fahrenheit, right? And that's because 0 isn't the starting point. We know in this country that you can go much below 0. And so when it is 20 degrees outside, you can't say that it's twice as hot as it is when it's 10 degrees. So what's the only scale in terms of temperature that is ratio in nature? Yeah, it's a Kelvin scale, where you start at absolute 0, which is about minus 260 degrees Celsius, where supposedly all atomic motion stops. So mostly we're not going to be making the distinction between interval data and ratio data. Ratio is part of interval data. Usually we're talking ratio, but we'll be talking about nominal versus ordinal versus interval. The nice thing about interval data is that you can calculate means and standard deviations and medians and all sorts of measures, as well as all the other stuff that you can do with nominal and ordinal data. All right, that's actually where I'm going to end it today in this particular very short lesson. And we're going to continue on with constructing graphs in the next one. Thank you.